Okay, question number 19. We have diethyl oxalate. It's a solvent. It has an empirical formula of C3H5O2. And that has a molar mass of 73.08 grams per mole. But the entire molecule has a molar mass of 146.14. We divide that, and we end up with 2. So that means our molecular formula is going to be 2 times C3H5O2, which gives us C6H10O4. All right, so this is the granddaddy question. This is question number 20. We have 64.8% carbon, 13.67% hydrogen, and 21.59% oxygen. We're going to figure out what the empirical formula is. So we're going to assume a 100-gram sample, which means that we're going to have 64.8 grams of carbon, and we're going to end up dividing that by 12.01 grams per mole. And this is the carbon. We have our oxygen. Well, I guess we can do the oxygen. So that's going to be 21.59 grams of oxygen, and we're going to divide that by 16.00 grams per mole. And we also have hydrogen, which is 13.67 grams per mole, and 1.01 grams per mole, and the units, of course, on the top should have been simply grams. There we go. So we're going to figure out how many moles of carbon we have. So that's 64.8 divided by 12.01. So that means that we have 5.
With the assumption that all students are now on the buses, if they required it, the buses would leave in 30 or so seconds. Thank you.
So 5.3955 moles. 21.59 divided by 16 gives us 1.3493, well, I guess it should be 94 moles of oxygen, and about 13.535 moles of hydrogen. So we're going to divide each of those by the smallest number. So we take 5.3955 moles, and we divide it by 1.3494 moles. And this, of course, is just going to end up being 1, because we're going to divide by the exact same number, and 13.535 moles, and we're going to divide it by 1.3494 moles. So let's do some division. 0.3494, so that works out to be about 10. And over here on the other side, 5.3955 divided by 1.3494 gives us 3.99. So that means that we're going to have C4H10 and one little tiny oxygen. All right, now we have to figure out what the molecular formula is. Now in part B, they give us a 5-liter sample, so a volume is 5.00 liters, and we have a mass of 16.7 grams. And like I said, this is the granddaddy of all questions. Because what's happening here is they give us enough information to figure out how many moles we have using the volume, and enough information to figure out what the molar mass is given mass. So to figure out the number of moles, we're going to take the 5.00 liters, and we're going to divide it by 22.4 liters per mole, which means we have 0.2232 moles. To figure out the molar mass, and this is the only time in this unit that you're going to figure out the molar mass, but we take our 16.7 grams and we are going to divide it by 0.2232 moles, and that's of course how we're going to get our grams per mole as our units. So we take that number and we do the division. 16.7 divided by 0.2232, which gives us 74.816 grams per mole for our molecular mass. So we have to go back to our empirical formula, which was C4H10O. So we had C4, H10, and O, and the molar mass of that is going to be 12.01 times 4 plus 10 times 1.01 plus 16, 74.14 grams per mole. So clearly that is going to be our empirical formula as well as our molecular formula. And that concludes your video key to your Unit 1 test.
Just for teachers, the report cards that you got today are the report cards that are going out. The only reprints will happen if there's an